Okay, in the last video, we kind of got Simulation Express all set up. We went through it, what it is, what it does. You know, it's a powerful tool, all that. Now we're going to go ahead and we're going to do a simulation on this. And so if I click my Simulation Express Analysis Wizard, it's going to give me some options. And the options, we want to make sure that the system of units are SI, because that's what we're going to be working in. And then if you want to save the report somewhere, we can select that. Because I've done this before with this part, I'm going to do start over. We'll say yes. I apologize for the small font. I'm not sure. I was actually kind of looking into that, and I'm not sure exactly what is going on with my SolidWorks, but I've tried to make a couple adjustments, and everything else looks normal, but for whatever reason, this Simulation Express box comes in really small. And so the first thing we're going to look at is it gives us some options here, and we've got fixtures, loads, materials, run, results, and then optimize. And so the fixture, we're going to add a fixture. And what the fixture does is that basically locks down what we want to remain fixed. We can rotate parts about that, or when we apply a force to it, you know, we have to have one part that doesn't move. Otherwise, once we apply force to it, it'll just move it across the screen. And so because this is a wheel, we can envision that there's force put around that rim, and so we probably want to make that hub stationary. And so if I flip this part over and I click on this cylinder, I want to click on the round part of the cylinder, and I also want to click on that square face. And we're going to hit OK. And now you can see it's got these let me zoom in on it. So these green markers, that is indicating that that is fixed and it will not move. And so now if I flip the part over, I can either add another fixture or I can edit the existing fixture. So we're going to move on, and you can hover over these, and this shows you some examples of when we fix different areas on the part. And this is like if we fix faces and what it's doing, and you can see a load pulling up. Here it shows the load and where they're fixing the end, or they're making the end of the shaft fixed. And then here they're making that plate fixed, like say to a wall, and then they're fastening it with fasteners, and they're basically putting a force on trying to pull that thing away, right? And so that plate's supposed to be fixed, but you can see where it was bending. So now we're going to go ahead and we're going to go next, and now we can add a load. There's two different kinds of loads. There's a force and there's a pressure. And so when we add a force, think of a point, think of a shelf, and where we put, say, an arrow pointing down on a shelf, that's a point load, and that load of, say, 50 pounds is going to be placed on that point, like where we put the arrow. And versus if it was a pressure of 50 pounds, that's going to be 50 pounds of pressure distributed across that whole shelf. And so it's different. Now we could add multiple points of force and say we had 3 points of force that are 50 pounds on that shelf. That's going to be a total of 150, but in 3 points. Versus, you know, a pressure of 150 is going to be distributed across that whole shelf. And so we're going to add a force. And we want to add a force. You can see in this model, it's a little different than the one that we modeled. It's got a boss on it. And so I'm imagining that this boss would be like a handle. And so we're going to click on that cylinder. And then instead of normal, which the force would be going in all directions, you know, distributed around that cylinder, we're going to select a direction. And now it gives us something else to to select that direction. And so what we're going to do is we're going to come here with our flyout menu, and I'm going to select the right plane. And now you can see we have these arrows going in that direction against the plane, but inside the hole where we've constrained them. I could reverse the direction if I want. And then we can either direct the forces to be per item, like if we had 3 separate loads, or in total. Because we're only applying one load, we're just going to leave it. Our units are SI, and our force is going to be 3,000 newtons. And then we can say OK. And now we've done that. We can edit if we want, but now we're going to go next. And even though we chose the material for the part, it's kind of making us just confirm that we're sure that we wanted to do that. And so we're going to say choose material, and we're going to go back in under copper alloys, and we're going to select aluminum bronze, and we're going to choose apply. And once we've chosen apply, we can hit close. And once we do, we can see that aluminum bronze has been put here, that it's been assigned to this part. And then it shows us the Young's modulus and the yield strength. A little hard to read, it's small. And that's those are the material properties that it's going to use to run this test. And so we can either change material, or now we're going to hit next. And so at this point, we can either go back and we can change the settings, or we're ready to solve it. And so at this point, we're going to run the simulation. And now you can see that in animation, it's showing what that part would do. And here you can see the hub is fixed, and you can imagine a force being applied here, and that's kind of what it would do with that amount of force, is it would try to bend that rim. And we can stop the animation. And over here, I've got results. I've got 4 results. I've got my stresses. And if I double click on each one, where it's in the green, this arrow here is my yield point. And what's my yield point? My yield point is of a material is where that material bends and will not come back. Anything under that arrow, if I bend it that far, it'll come back to its original position. Once we go over that arrow, it's going to start to become what we call plastic and not come back. And then obviously when it gets too far, it's going to fail. So those are my stresses. I can look at my displacement. And so you can see in the red, I can see I've got yellow, I've got some, greens, reds. So those are going to be a fail point more than likely. But where it's blue, there's absolutely no problem with that. So if I double click on my displacement, I can see obviously this is distance in millimeters. Because our force is applied on this hub, that's where I would expect the most movement. Because we made, or I'm sorry, on the rim, because we made our hub fixed, that's why it's blue. My deformation, you can kind of see it's trying to, let me try this again. The deformation, it's really hard to show, but in real graphics mode, it kind of shows where you can see the metal kind of deform on it. And then our factor of safety. And so our factor of safety, anything under 1, and you can see this is a negative exponent, so that is under 1. It's 6.37 to the negative 1. That's why it's red there. And it's pointing actually to here, but the other side is affected as well on each of the spokes. Anything under a factor of safety of 1 is a fail point. Anything over, we're safe. And so we've got a min and a max, our factor of safety. And so that could become a problem. And so now we can go back and we can look and see what we want to do. Do we want to change the part? Do we want to do we want to edit something? And so we're going to stop the video here, and then we're going to pick up exactly right here, and we'll do one more short video on how we're going to let SolidWorks analyze this part for us and determine what we should do with it to fix that factor of safety and then fix our design so it does not fail.